So vaccine preventable diseases, that is the VPDs. Vaccine against a range of bacterial and viral diseases is an integral part of communicable disease control worldwide. And we know that a lot of morbidity and mortality have been averted as a result of vaccination. And that is why it's considered as one of the great achievements of the 20th century. So vaccination against a specific disease does not only reduce the incidence of that disease, it also reduces the social and economic burden of the disease on communities. And that would entirely mean control. Remember, we said control involves reduction in incidence, duration, complications, and also the financial burden both to the individual, community, and the nation at large. Very high immunization coverage can lead to complete blocking of transmission for many vaccine preventable diseases. And the worldwide eradication of smallpox and the near eradication of polio are examples of what is possible with vaccination. So as we know, polio has been eradicated from many places in the world. There were 5 of us that were pulling the world behind. Nigeria has, 3 of us, Nigeria has exited that pool. Initially, it was pain, well, the pain of the world, that is Pakistan, Afghanistan, India, and Nigeria. And then later on, it went to PAN, that is Pakistan, Afghanistan, Nigeria. But presently, Nigeria has eradicated. So I think it's the PA that is left, and it's understandable because those 2 places are war-torn. So that could be one of the reasons. And with the whole insurgency, I hope that we don't go back to what we have overcome. So I'll just give a few examples of these vaccine preventable diseases: tuberculosis, diphtheria, tetanus, pertussis, or what is known as whooping cough, poliomyelitis, or polio, measles, mumps, rubella, Haemophilus influenza type B infections, hepatitis B infection, influenza, pneumococcal infections, yellow fever, cholera, hepatitis A, meningococcal, plague, rabies, Lassa virus, Japanese encephalitis. But this Lassa virus now, Lassa virus, that is bat Lassa virus. Sorry to say, not Lassa. Lassa is a Nigerian, in quote, West African problem. So there's no vaccine for that presently. So Japanese encephalitis, Q fever, typhoid fever, and varicella zoster or chickenpox. So these are some of the vaccine preventable diseases. So we'll talk about the types of vaccine. So vaccine is an immunobiological substance designed to produce specific protection against a given disease. It stimulates the protection of protective antibody and other immune mechanisms. So the vaccine prepared may be the form of live attenuated, using live attenuated organisms, inactivated or killed, extracted cellular portions such as maybe the protein, part of the capsule, or receptors on the capsule, something like that, or the DNA or RNA, as in the case of the newer vaccine technologies that have been long researched for HIV, but however have been presently used in the case of COVID-19 disease. And then toxoids, we have example of toxoids, the diphtheria, pertussis, as well as tetanus. And then combination of these, they can come in all varied form, conjugated with this and that. So I wouldn't want to bug us too much with that. I hope I have that which differentiates live and killed vaccination on the slide, but if not, we can check it up. I think I've dropped some of the textbooks with your chief, so he would share with you. So these are basically what the types in the preparations in which the vaccines are. This is what they are. So this is a table of the types of vaccine. So just looking at whether the vaccines, whether they belong to live attenuated, killed whole organism, toxoid protein, polysaccharide, glycoconjugates, or recombinants. So looking at that, for the live attenuated, we have tuberculosis, yellow fever, polio, measles, mumps, rubella, typhoid, varicella, rotavirus, cholera, cold adapted influenza, rotavirus, resultant, and zoster. So something to note about the live attenuated vaccine, the code we usually use, though it does not cover all, is Mr. Mosby. That way, you don't forget it. Or some will say Mr. Boy, anyone that works for you. That is Mr. Mosby looking at measles, mumps, rubella. Then that is for the MRM. Then O, I think it's oral polio. I'm forgetting it now. Mosby. Then B is BCG. Y is yellow fever. Can't remember what the S is now, but these are the live attenuated vaccines. Okay, so looking at the killed, and then even in the mode of administration, if you look at some of the live attenuated, like polio, rota, they are administered oral, that is for those two. For the killed form, they are majorly IM, and you have typhoid, cholera, plague, pertussis. For the pertussis, there are two forms. There's a type that is killed, and then there's an acellular form that is toxoid. So just take note of that. So it can fall into either group. So influenza, typhus, polio, that is the IPV type. There are two types of polio, and the way to differentiate them, which can either be live attenuated or killed. Sabin is the live attenuated, then Salk is the killed. How to differentiate or to remember, memory help is that Salk has K, so that is the one that is killed. Then polysaccharide, we have pneumococcus, that is PCV, meningococcus, hip, that is Haemophilus influenza type B, and then typhoid also. Then the glycoconjugates, we have still another type of influenza also falls into that group, another type of influenza, and then pneumococcus also, as well as men ACWY. That is for meningococcal against serotypes A, C, W, and Y. Most there's usually no vaccine against B, meningococcal B subtype, because it's not effective. Then for the recombinants, we have hepatitis B virus, Lyme disease, cholera, toxin B, and human papilloma virus vaccine. So just for us to take notice that it just, even if we may not be able to memorize all, but the key ones that are common in the various groups, it would be good to just have them in mind and to know what group they fall into. So, okay, this is a table I was talking about, differentiating killed vaccine from live vaccines, and these are actually common MCQ questions. So in terms of number of doses, for killed, you would need multiple, but for live, a single dose will likely suffice, and that is because it produces a stronger immunization. It challenges the immune system more and tends to produce a stronger and more lasting immunity. So need for adjuvants, the killed will, the life attenuated does not. In terms of duration of immunity, is shorter for killed, longer for life. Effectiveness of the protection is actually lower for the killed and then greater for the life. Immunoglobulins produce, the killed is majorly that of IgG, while life produces both the IgA and IgG types. Mucosal immunity produce for the killed it is poor, but for life, yes, we have it. Then cell-mediated immunity is also poor in killed, but present in life. That's why you have that BCG can offer both. It offers both cell-mediated and also humoral when given. Just take note of that. Then for the residual virulent virus in vaccine, because the killed is a killed organism, it's not possible. Residual virulence in vaccine, so it is not possible. But for what do you call it now? For the life, it may occur. Then reversion to virulence in killed, no. Sorry, the first one is residual virulent virus in vaccine. You know it is killed, so if it is all not effectively killed, you might still have some residual, but in life, it is not possible. But in case of reversion to virulence, that means the organism you've given becoming virulent again, reversing back to virulence. You don't have that in killed, because if they are killed, they are killed. They cannot reverse to virulence. That is, if they are effectively killed. But in the case of live vaccine, it is possible. And that is why, one of the reasons why Salk is being introduced is the fact that we're beginning to have circulating vaccine polio. So that was one of the reasons why we are now tending towards using, moving towards using the Salk, so that this particular hurdle can be overcome. So excretion of the vaccine virus and transmission to non-immune contact, this is not possible in killed if it's effectively killed, but it's possible in life. This is still part of the reason for the movement from Sabin to Salk, because of this. Because once these children who take the vaccine excrete the organism in the stool, other non-immune children could actually pick it up and come down with polio. Then interference by, sorry, am I still heard? Okay. Interference by other viruses in the host. This does not occur for the killed vaccine, but in the live attenuated vaccine, it is actually possible. Then stability at room temperature. We know that for the killed, it can withstand high temperature, but for the live attenuated, it needs to be kept under specified low temperature. So immunization program in Nigeria, we have certain diseases that are targeted in our expanded program.